Hi everyone, this is the first follow-up lecture for Chem 345 where I'm going to go over some questions over Piazza on this. So, one of the first questions on Piazza has to do with the March 13th lecture, where we went over bromination, and since the methoxy group is an ortho-para director, you get ortho and para. Now the major product, you get when you have an ortho-para director is a para substituted because of because of sterics. Typically the para is major over the ortho. Now, I also said during that lecture that in reality, if you were to try to do this with bromine, the actual major product that you'd get is this. If you actually want to stop here, you would actually need to use some very specialized conditions. And one set of specialized conditions is NBS and acetonitrile. To get to there. With that said, I don't want you to have to remember each individual conditions and what it does. So this is a bit of a lie, but the rule for this class is going to be if you add a deactivating group in an EAS reaction, you will stop after a single addition. So on exams, if I want you to make this product right here, what you would need to do is do the reaction three times. That way, adding a bromine, you just have to remember these conditions, as opposed to figuring out specifically what conditions necessary to add one bromine on, because NBS acetonitrile works on this molecule, it won't work on deactivated, on non-activated rings like benzene. So rather than having to remember all of that, you can just remember this. In this class, if you add a deactivating group in an EAS reaction, you will stop after single addition. So that's the first thing. Second follow-up reaction, this is a follow-up question, had to do with the problem sets. The question was, in this reaction, do you have to worry about the bromine reacting? And the answer is no, you don't have to worry. Vinyl halides and aryl halides do not react in EAS reactions. The reason for this is the resulting carbocation too high in energy to form. And even with a strong Lewis acid, it's unlikely that the halide is going to be able to be pulled off to form these carbocations. So as a result, they're not used in EAS reactions. So you can safely say that only the acid chloride here is used in the EAS reaction. We clip off the Cl, clip off the H. There. Now, the last question that was on Piazza was wondering if you couldn't do this reaction here. And make that a new bond. And it's awfully tempting because this is a meta director, and the product has the two carbonyls, meta to each other. But alas, that is not possible because the Friedel-Crafts reaction has a limitation. It generally fails when a strongly deactivating group is on the aromatic ring. In this class, what we're going to define as a cutoff point for a strongly deactivating group these are the meta directors. Okay, and that seems to be all the questions. So, until next time,